All right, 12.1.2, inverse trigonometric ratios. So it's called the inverse trigonometric ratio because that's what we use when we want to find the angle measure. So you'll see some examples coming up. So the inverse trig functions. So yesterday we introduced sine, cosine, and tangent. Today we are introducing the inverse sine, the inverse cosine, and the inverse tangent. These inverse trig functions are used to find the measure of an angle when you know two sides. And on this slide, I'm showing you the notation here in this column. Tangent raised to the -1, sine raised to the -1, cosine raised to the -1. These -1s, they're not exponents. It's simply the notation that means the inverse of. And when you want to calculate the inverse trig function on the calculator, instead of hitting the regular sine, cosine, or tangent button, you're going to hit the second sine, second cosine, second tangent. And that'll get you your inverse trig ratios. All right, so let's look at an example here. So we have a right triangle, and it says find the measure of angle A. So we're trying to find angle A right here, that angle. So we're going to start out the same way as we did when we were finding the side lengths. We're going to choose the correct trig ratio based on what the triangle is giving us and what we're trying to find. Now, obviously, we're trying to find angle A, so that's the angle we're starting from. Looking at what side lengths we know the opposite side is 8, and we know the adjacent side is 15. So we're going to choose tangent because opposite over adjacent is tangent. So here we go. Tangent of angle A, which is what we're trying to find, equals our opposite side length over our adjacent side length. Now, yesterday I talked to you about how this is one term. You cannot separate the tangent from the angle A, right? And I stand by that. But we need some way to solve for angle A. The way that we do this is by using the inverse tangent. The inverse means the opposite, right? The inverse will undo whatever has been done. Well, in this case, what's been done is the tangent. So we need to undo the tangent by taking the inverse tangent. And if we take the inverse tangent of one side, algebra tells us we have to take the inverse tangent of the other side also. So I have to take the inverse tangent of 8 over 15 as well. This is what gets us angle A by itself, because now the inverse tangent undoes the tangent and gets us angle A all by itself. And what it equals is the inverse tangent of 8 over 15. And this is what we can plug into our calculator. Second tangent, 8 divided by 15. Remember, make sure your calculator is in degree mode. Hit enter. 28.07. So this means that angle A equals 28.07 degrees. It's pretty common for the directions to ask you to just round to the nearest whole degree when you're finding the angles. So in this case, we'll say A equals 28 degrees. Second example, given a triangle, it's kind of been rotated slightly, so it might be slightly more difficult to figure out what is what. And we're being asked to find the measure of angle X. So angle X down here, that's what we're trying to find. So that's the angle we're going to start from. Looking at the side lengths that we know this, which is going to be opposite, and we know this, which is the hypotenuse. Opposite over hypotenuse is sine. So I'm going to set up my trig equation. Sine of angle X equals the opposite side length, 11, over the hypotenuse length, 21. Again, we need to solve for that angle X. We need to get it by itself, so we need to undo the sign, and we do that by using the inverse sign. And if we do it to one side, we have to do it to the other. The inverse sign undoes the sign, leaving us with angle X all by itself, and we can plug this right into the calculator. Second sine of 11 divided by 21 equals 31.6 if we're rounding it to the decimal. Degrees, if I'm asked to round it to the nearest degree, 32 degrees.